Okay, actually, I'll do a little bit more. I read a couple comments on the video I posted during my planning today. And first of all, it has 240 views and max what? I have like 86 students this year. So there's a lot of people watching it that are not my students. And the comments are very motivating, so I'll do another one. Here we go. All right, so just did the one that I'm sure is everybody's favorite. Yay, the chemistry, it's the worst. Just kidding. It's the best. No, it's the worst. Okay. Um, but talking about productivity, so it's the rate. The next question for that is you're looking at the mean or the average primary productivity or the average rate of organic material synthesis per area per year. And if you notice too, like this question right below it, this doesn't happen often, but this question could definitely give you answers for this question. So notice like you could get another mark for that. This is rare, this doesn't happen, and this could definitely just be like a mistake on them making this test. When I go over paper two tomorrow and the next day, I'll show you like directly where there is a mistake, and it actually drove me crazy. But anyway, but it's in per meter squared per year. So area, and then like the time unit, and then of course like the mass. Well, they have it right here, grams per meter squared per year. Awesome. Okay. And so then that can go right here. I mean, kilograms wouldn't be wrong. It wouldn't, depending on like the area you're trying to measure. Okay. So great, 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 great. And then it also shows you the total primary productivity per year in different regions of the world's oceans. Okay. And this is total, like with their entire area. This has the entire area, where this one is just like in a meter squared on average. So if you divided them, like if you divided the 190 by 10.45, right? Now I'm going to do that math really quick before I misspeak, and then I'll erase it and act like it didn't happen. It didn't happen. Anyway, okay. State which region has the lowest average primary productivity, and so that's your 1 mark, and suggest a reason. That's the second mark there, and it's 2 marks. Suggest a reason for this. Okay. Lowest average 55, 206, 27, 290, 1050, 1410. Cool. There you go. So it's going to be polar. And then the reason, it's a polar climate, it's a polar biome. There's lower light penetration. Sometimes there's not even any light. And if you're not going to have any sort of light, then you ain't going to have photosynthesis. And if you're not having photosynthesis, then your productivity is really low. And that's it. Not only that, whenever we consider things not having light, that's going to be like your main heating vector too, is like through solar energy. So when you don't have a high temperature or warm enough temperature, enzymes will move really slow, and like essentially everything's going to move really slow. Here in Florida, whenever it does hit for like the 2 max, maybe 3 days, but usually it's like 2 days in Florida when we have like freezing temperatures. The iguanas that live about 2 hours south of us in Miami, they'll fall out of the trees, and people grab them really fast because otherwise they can't catch them, and then they eat them. But yeah, they'll fall out of the trees because their enzymes are moving really slow. and they're just essentially like just surviving. So the answer is going to be low light penetration. If it said and explain a reason, you would say low light penetration and then like photosynthesis. Or not even light penetration. It's not even that. It's like low light intensity. It's not like there's a ton of sediment like preventing light from penetrating through the water. There's just not a lot of it. Another thing you can say is low temperature. Explains why coral reefs are the region with the highest average primary productivity. So the lecture video I did Monday morning, of course, at like 14 minutes, it's like, whoa, whoa, whoa. I don't know why that happens. It's frustrating, and I can't figure out an answer online, but moving forward. Um, comparing like comparing marine ecosystems, where like hydrothermal vents are extreme, but they're stable because they're just always an extreme hard place to live at. And uh sandy shores are non-extreme, right? Like there's sunlight, it's not anoxic, so there is oxygen there. It's not acidic, and the temperatures don't fluctuate from like near boiling to near freezing. The pressure isn't extremely high, you don't have heavy metals, all that. Though it's not extreme, it's very unstable, and that's hard for organisms to adapt to. Sandy shore is easily erodible. The sandy substrate's very porous. You really can't have organisms like your producers anchoring on there. Hold fast can't attach to anything. Roots can't anchor into anything because it's going to be eroded. It's going to be eroded at least twice a day. It's easily eroded by water, by sand, by tides, by currents. And so you just have to, like, the only way you can survive is by being a burrower. And with that, there's really no producers there except for anything that the tide brings in, which would just be your phytoplankton. And so they typically, organisms there are going to feed on like dead, decaying material. Okay, so this is mainly going to be because it's a wonderful place. And don't write that. But in terms of what makes it a wonderful place, we're going to talk about like the high light intensity, and that's going to be great for photosynthetic organisms. Something I've already touched on then with the notes I posted on Google Classroom. And yeah, and then what I talked about yesterday, literally, it's like as soon as the slide with the star on it. I'm not going to say it's like one of the most important slides, but it's one of the most important slides. And one of my students said putting the closed captions on should be helpful as long as I'm not talking too fast or it's able to still understand what I'm saying, even though it's slow, but curses. Yeah, they have to live in an area that doesn't have much sediment. So it's not gonna be by like human areas where there's a lot of runoff. It's not gonna be by areas of upwelling because that's just gonna make the water turbid and sediment scatters sunlight. All right, so there you are. Remember, corals are an animal, but they have a mutualistic symbiont living inside of them, and that is their zooxanthellae. Otherwise, corals are just like a big straw filtering out particulates from the water, and there really are not a lot of particulates in the water, or else it would be very cloudy. So the zooxanthellae will supplement them by giving them some of the organic material they synthesize, and in return, the corals will give them carbon and a lovely place to live. Okay. I guess you could also say like in many photosynthetic organisms, but I feel like zooxanthellae is going to be a better term to know. I'm surprised at this next mark saying temperatures are warm. Um, this is like their go-to range, but their favorite 23 to 25 degrees Celsius. That is their favorite. I always remember 23, again, because of LeBron James's number when he played for Cleveland. And of course, Michael Jordan. Temps are warm. I'm surprised. Yeah, I'm surprised this mark doesn't say like throughout the year. Like it's not seasonal. It's always like that because they're like tropical. But or temps are constantly warm. I don't know. I don't trust it. Anyway, um, live in shallow waters. Um, yeah, they live in shallow waters or the water is shallow. So all of these things are kind of setting up like a really nice situation for maximum light penetration and photosynthesis. The water is clear, it's not turbid, or like even low levels of sediment. Again, if you would ask me, like, Miss Pear, do you think I can write this on my test? Don't write it. One, you can't ask me, I want to say tomorrow, today. You can't ask me, but if you have to ask no, then just assume no, write it out. Okay, so all of these are going to be setting up really good scenarios for photosynthesis. You only need 3 of them. Maximum light penetration or for maximum sunlight absorption. And all this causes a high rate of photosynthesis. No sense in saying something like, this all causes a high rate of productivity, even though productivity, it means rate. Like this causes a high rate of the rate of organic material production. You wouldn't, I mean, that's very redundant, but also you don't want to say what's in the question. Like you don't want to say this causes high primary productivity, because like that really isn't saying that you know anything, essentially. Like just try and find a synonym for that. A synonym. Explain why the continental shelf. Okay, so remember this is where like literally the continents like fall off the edge of your continents. And I've said so many times, like, even though like you guys might go to the beach and like, or somewhere over here, right, and like obviously the land comes a little bit higher. But, as soon as you go in the water, does not mean like you're on like Atlantic Ocean area. No. This is like oceanic plate down here. Oceanic plate's more dense, which causes it to sink. Um, cause it to sink and cause it to subduct under a continental plate. There really are not tectonic questions on here. What a bum. And what else? I'm so tired. I'm trying to break through it. Yeah, so, all right. Continental shelf is this area. Anyway, but here's no upwelling. Continental shelf, why does it have a higher average like primary productivity? So like let's look back at the chart that they gave you. Higher total. Let's look at that total, not average. It's not the mean. Where like coral reefs had the mean, this is just the total. So it's the other the other data set compared to a continental shelf with upwelling. Okay. Let's erase that so we can see it. Okay. All right, continental shelf, no upwelling. And they didn't want the mean, they said total. So if I look back at the question, right? Total. Continental shelf, no upwelling. Continental shelf with upwelling. Okay. So even though on average, areas of upwelling, because when upwelling happens, it is like such a significant event. There are huge like plankton blooms and productivity is just run amok. I never say that. But there is one huge factor within this. So if we just consider this data right here and this data right here, they already told us this one's higher, continental shelf without upwelling. So there's only one other thing. Boom. And that's large, y'all. So that's like 26 million square kilometers. I just took it out of scientific notation. So instead of saying 26.6 times 10 to the 6, I just did that for us. Versus like 4, yeah, versus 400,000 square kilometers. 26 million, 26.6 million. That's your answer. You know, I mean, not like you have to take it out of scientific notation or anything, but the answer is it is such a larger area. Remember, upwelling is only going to happen where you're going to have offshore winds, strong ones, particularly blowing water off the coast. So you're going to have relatively low water pressure there, and the nutrient-rich water, colder, deep water is going to move up to take its place. Anyway, that's the only determining factor, right? Like they said, look at this 7.7 and then 0.42. How come? The answer right here is it's the size difference. So there's just so many more areas that like, you know, the continental shelf is on every single continent, every single continent, every continent, where you're not going to have upwelling everywhere. So it's like on the edge of all of those basins. Okay, okay. And it would be right there. Like, here's the shelf. You don't have to put this. You could also say the reverse argument. You could say upwelling areas cover a much smaller area. Yay, I love upwelling questions. That's not sarcasm either. It's just a nerdy thing to say, for real. Some upwelling areas, such as the Benguela upwelling off the west coast of Africa, And this is actually the area that's pretty that well, I guess it's like near the like the Cape, what they call it, Cape Verde coast. Um, is it Canary Islands? Something like that. This is where like all of our hurricanes come from. So the Benguela upwelling off the coast of Africa have the benefits of upwelling all year round. Ooh, explain how upwelling occurs. So explain is why and how. Let's do it. All right. I'll sketch it out here real quick. All right, so it's caused by offshore winds blowing water off the shore, away from the shore, right? Feel like you're cooling something down. And then you're just gonna have like an overall area of like low water pressure. Like now it's like you're missing water right here. Not literally, like we couldn't ever see this, but like physics wise, you are. So cold, nutrient-rich water from the bottom, and it's going to have a ton of nutrients down there because nutrients have mass, nutrients sink, are going to rise up to take its place. And its place, by that I mean the water that was blown offshore. It's going to bring along a lot of nutrients with it, and la-ti-da. This is where you can start making a mistake though, because you're going to be like, the nutrients feed the fish. Like, okay, when we get to like this question right here, we don't feed our fish nutrients. We don't feed animals nutrients. If you're like, oh my gosh, I'm out of dog food, you don't give your dog like fertilizer for the ground that's deadly. You don't do that. You know, animals, fish, humans, any kind of consumer, they do not eat inorganic things. We're not producers. We can't do that plant magic. We can't take inorganic and make it organic. So the mistake happens when students are like, boom, I got this, and you're like, nutrients rise, and then the fish eat the nutrients, la-ti-da, period. No, that's not gonna happen. It first has to go to the producer first. It has to go to the producer. And then through photosynthesis and assimilation, the producers will assimilate it to an organic material, whether that be straight up glucose or it is protein or nucleic acid or a lipid. It's no matter what, like that's where all of our organic material are going to be sourced from a plant or from an animal that has eaten a plant. These are offshore winds. I don't like that term replace it, but it is on the mark scheme, but I would say to replace it, and then I would say the displaced surface water, or like the water that was blown away. All right, so in short, it's the movement of cold, nutrient-rich water from the seabed to the surface caused by offshore winds. There you go. just the benefits of the good thing. To local fisheries of year-round upwelling. Okay, remember, it goes nutrients. This is the inorganic cycle. Okay, there you are. When in doubt, draw it out, right? Inorganic, not alive. Alive! These are your producers. Primary consumers, that includes zooplankton. And then secondary consumers, second eaters. And just for the sake of the test being in like 12 hours, increase in nutrients for higher productivity, or you could say there's an increase in nutrients for a higher rate of photosynthesis. Higher productivity, again, productivity is the rate of photosynthesis. It's the rate of organic material production. So you could say higher productivity because productivity is the same thing as saying this. These are equal. They're the same word, the same phrase. Increase organic material. We can say biomass for the food chain. Or you could even say for trophic levels. So you can also mention you will increase the number, like the amount or like population of fish, or it's going to increase their size of fish, like they're going to grow bigger because they have more food to eat. Or both, but don't use the word and because you don't want to contradict yourself. And you got to take it to benefiting local fisheries. Fisheries are like fishing companies, fishermen, fisher people. Increase money, or don't use that $sign on your exam. That's American dollars. Don't use that. Don't use that. The pound is different, so we're going to say increase income or revenue or profits. or increase in catch, if that works for you, like an increase in like the amount that you're able to harvest. Okay. I'm probably gonna do this one in the morning. 5. Um, I did this one last week, the Sandy Shore question, on a separate video. In class, I did mangroves on Friday along with my own note page for it and posted that answer. We did this one in the beginning of the year. And then using examples, the importance of maintaining global marine biodiversity. We did this like 2 weeks ago. Before I do this one though, and I will do it in the morning because I do need to be somewhat of an adult and go to bed. This question, in my opinion, is poor for multiple reasons. One, it's 8 marks. Why? Why is this question 10% of the exam? Like, why? Please, why? Please, why? And you need, like, this is something that I would think it would be like an environmental, like those huge essays that they used to have. Like, this is a grade determiner right here. Like, in your answer, include reference to the 4 main types of erosion. What? 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 TBH, I had to look them up. No, I didn't. I would have had to. I didn't. I mean, of course, I have like access to the mark scheme, but like, what? One, there's no other time where I can't even recall in any of these marine tests that they've talked about ice erosion. There's no other time in the syllabus really I've seen them like talk about ice erosion. If they want to do like some kind of like compare the morphology or like how a sandy shore versus a rocky shore versus a delta gets created, cool. How about comparing how like a hydrothermal vent is formed or a delta or like what? Reference the 4 main types of erosion. That's 8 marks right there. And then um, weathering and erosion affect the type and morphology of shorelines that develop in the littoral zone. Um, they don't even really open up that answer as much as they actually should. But like 8 marks, 8? Like you can have an 8-mark question, but have it be valid. Like this is for what? This is not like a marine geography or marine geology class. It's so poor. 10% of the grade is this question. Like, so what if you couldn't just do blank recall on just what those are? It's so bogus to me. It's just a poor question. And it is poorly marked. Poorly marked. Maybe you could do like one of those Venn diagrams and, I don't know, show those different littoral zones and decide if it's sedimentation or erosion like that's creating it. But y'all, come on. Um, the shorelines that they mention, they in the mark scheme they reference rocky shore as they should. I mean, not like I approve this question by any means. 8 marks. I don't know. And then I think like how many different people had to like critique this test? Like who vetted this? Who was like, that's a great question. That's that right there. That'll do it. Um, it's no. And don't be intimidated if you come across a question that you're like, what? Because if you feel relatively confident with this and you're feeling that way, a lot of other people will feel that way. Like I'm really disappointed in this. Like you had time to rebuild this syllabus and 2 thumbs down on this question for sure. Okay. It says, yeah, so explain how erosion can affect the morphology of the different types of the shore, and explain how in its erosion is like the movement of sediment. Where weathering is, it's weathering then erosion. Weathering, you have to break the sediment to smaller pieces and then you can erode it. You can move it. Oh, excuse me. You cannot move a boulder. Like this isn't a tsunami. You can't move a boulder. Like, what about that? Like, compare the tectonic events or tectonic effects at a divergent boundary versus a convergent boundary or something. I mean, ask one of those dumb abyssal plane questions even, but I would even go as far as to say, like, bring back a monsoon, but I don't. Anyway, of the different types of shores, in your answer, reference the four main types of erosion. So you need to just have a quick recall of those different shorelines that you can talk about. Any four from, and here's where I'm also going to complain about this. So they allow the rocky shore, sandy shore, muddy, or the estuary. Estuary is like our Indian River Lagoon. Hey, hey, how about the freaking delta? What in the world? What in the world? The syllabus had like solid, you need to know delta. Like I worked on that. I worked on that because I wasn't going to be burned by the delta question again. Come on. Why wouldn't the delta be on here? Blows my mind. Just blows my mind. I would go delta anyway and be like, I hope you can accept other valid points. Thank you. Good day. Because this is definitely majorly made from erosion and then slowing down and sedimentation. Ugh, curses. Um, the four main types of erosion. Ooh, excuse me. Shoot, what I got? Erosion's moving things. So, there's water. Obviously, it's gonna be like runoff. Wind, glacier or ice. That's like how the Great Lakes are made. Huron, Ontario, Michigan, Erie. Whoop whoop. That was like I grew up by, and then Superior. I only remember that because of this acronym. Homes. Homes are your Great Lakes, Huron, Ontario, Michigan, Erie, and Superior. That has nothing to do with this test. Let me see this page and then this page. Shoot, I think I can do it. I'm not going to do it though. Be an adult. Go to sleep. Go to sleep. All right. Because then I just have part B to do. Okay. And this is all question 4. All right, cool. All right. I'll do it in the morning. Bye.